My name's Jason Wayman. Some people may have met me over the past years. All right, so our title, obviously, like cold outside, question mark. A little bit of proof where I'm sitting in Holly, Michigan. We actually got our maybe second snowfall of the year yesterday. And as you can see, I've been a bit of a slacker. I haven't even cleaned out the driveway yet. So I have some work to do this afternoon, hopefully before the sun goes down. With that, we'll jump back into the presentation. So a little bit of background, and this is not going to be a theoretical presentation by any means. As you can tell already, I even was good and put my references on the slide. I just went and pilfered some information from Wikipedia. But mostly we're talking about thermocouples. And thermocouples, I think the engineers that do noise and vibration or durability measurements, they know, yeah, it's something I need to measure temperature, whether it's, it could be temperature in an oil sump, a brake rotor, something on an aircraft, whatever it might be. You need those to measure temperature. But oftentimes it can be maybe expensive, I'll call it, to use your expensive LMS SCADAS system that can sample it, hundreds of thousands of hertz per second to measure temperature. And maybe you want a different way of doing that. So we'll get into the specifics of the hardware, but thermocouples in general are really just using an electrical conductor based on the difference in resistance between some various materials can be used to measure temperature. I put a quick note on here. I've got a slide coming up that talks about different thermocouple types. K, I think, is the most common one out there. If I talk to like our service people, it's pretty good all around thermocouple, but there's different types that we actually do support. If we look at this next slide and talk about those different types of thermocouples, you can see K here at this list. It talks about the high and low range. It has some information. Again, this is like just a straight screen grab from an article on Wikipedia, different wire types, etc. But essentially, we're going to have to use these thermocouples and their known properties based on their type to quantify temperature in Simcenter Testlab and using the Simcenter SCADAS hardware. So if we talk about how we do that with Simcenter SCADAS Lab, mobile recorder, etc., there's a few different ways we can measure temperature. And I wanted to clarify that today because now and then it can be confusing and some people think, oh, I have to use a whole different measurement system in order to be able to measure temperatures. Well, we have various types of ways we can accomplish that inside Simcenter Testlab. The first, if you are not aware, is that we have an 8-channel thermocouple input module. So in a normal slot of a SCADAS mobile, SCADAS recorder, etc., you can put what's called a T8A module, T for temperature and A for 8 channel. This module does support a very wide range of thermocouple types. So I think it's all those are on that slide I showed earlier. I'd have to double check exactly. But by selecting the type in the software, and I'll show this later on, it makes the adjustment automatically. This has galvanic isolation. It's part of the whole 24-bit sampling inside our DAC. It actually can sample at 25 kilohertz, even for temperatures. So normally people will say, it's a temperature. I don't need to sample more than once a second or something like that. But it is possible that you're looking for fast thermal transients, in which case this module would be very good at that and likely give you a big advantage over most, I'll call it temperature only measurement systems that typically sample much more slowly. In addition to the T8 card, we have the possibility to use a CAN bus based thermocouple acquisition through our TCK8, the thermocouple CAN bus modules. And you notice that it talks about an A and a B version here. So these two little modules stacked together, I'll show them later on when we get into the live demo. I have to have one A version as like the quote unquote main unit, and then I can have multiple B versions as the secondary unit. If you are powering these with our CAN 4 card that we'll see in the demonstration later on, I can actually plug in a total of 4 of these, 2 and 2, to get up to 32 channels of temperature measurement coming into a CAN 4 card. So there I would be using one slot in my front end to measure up to 32 channels of temperature. With the T8, of course, I'm using one slot but only getting 8 channels, so the channel density is higher going this CAN bus route. However, it's also possible, because it's generic CAN bus, to use these TCK8 modules with the built-in CAN that's on most of our Syscon modules. And I'll point this out in the demonstration later on, how we can do that. The one caveat, the catch, is that when I use this CAN 4, we power these modules and measure the signal all in one cable. If you use the built-in CAN bus on the Syscon of a front end, then you have to power these modules externally, which means you're carrying on some other kind of power supply, but you actually could then do more channels because these can be stacked up into 4, 6, 8, 10 groups of 10 and powered with an external power supply because of the current capability it has. The CAN 4 card itself can only power up to 4 of these total for 32 channels. There's a third way that you could actually measure temperature, and I put this in here because it's not always clear. Can I just use my inputs I already have on my SCADA system? The answer normally is yes. Nearly all of our modules and input channels support DC inputs, but you do have to be a little bit careful that there's an offset EU required in order to get a proper temperature value displayed. Now, there are some articles out there that talk about even measuring this just in straight voltage and then recalculating what the actual real temperature is in post-processing. But these couple of links here in these articles actually can show that live. And if I switch over to the browser I had, change tabs for a second. So the first link in there is talking about this article that says, hey, I have an offset when I'm measuring temperature. Why is that? Well, it's because our unit system is referenced in Kelvin, and you have to put in that offset. And it's reasonably straightforward, essentially, is that for every, assuming your calibration is in millivolts per degree Celsius or degrees Fahrenheit, you just multiply Kelvin times the millivolts per degree and come up with that offset value. So in this example, and what I had in that screenshot of the slide, this was saying I have a 5 millivolt per degree Celsius transducer or thermocouple or any kind of external temperature measurement device. Then when I set it to temperature, I have to put in that offset 5 times 273 to come up with that offset there. As a quick Google search, I actually put my units in Fahrenheit today, so I'm using an offset we'll see later on of 459 times my sensitivity, and I'll point that out later on. In addition, maybe you don't know what your sensitivity is. You're using some kind of device that's giving you a linear DC voltage relative to temperature. You could actually create your own calibration value by using our DC calibration tool built into Simcenter Testlab. I'll show where this is in the software later on, but it's a little known, I think, feature that people kind of skip over. Normally they'll go to the calibration tab to maybe put an accelerometer or a microphone onto a calibrator and do a spot check. But this DC calibration tool lets you put in multiple points. And even with a thermocouple, you could use, say, ice water and boiling water. You could, of course, adjust for altitude if you wanted to be very precise, but put the thermocouple in ice cold water and boiling water, you get 2 points, and use that to come up with a millivolts per degree Fahrenheit or Celsius, whatever you're calibrating in. One quick tip on measuring thermocouples on a DC channel. So that's really all the background I wanted to cover today. I think we'll look at some live things in the software. Give me a moment here. I'm going to actually turn on my camera so you can see what's going. Awesome. So I'm going to jump now into Testlab, and that should be on the screen that's being shared now, I think, as well. So let me talk through the kind of things that we would typically set up for a measurement of temperature using Simcenter Testlab and Simcenter SCADAS hardware. So first of all, I kind of wanted to talk through the different things that I have plugged in today to make it clear as to how this is being done. First, you'll see that down here in the front end, I have one of these CAN 4 or CN4 modules that I talked about. And you'll see one thing right away is that, well, Jason, you said it's a CAN 4 and there's 2 DB9 connectors. How can you get 4 CAN buses out of that? Even people that have bought these from us in the past forget that we send this interesting cable here, which splits out into 2 different DB9s. So really that 9-pin connector is wired such that you can hook up 2 different CAN buses. Now I could come and plug, you'll notice back here on my chair, if I point way in the distance, I've got a TCK8 A and B module set up, and there's the thermocouple from that going over there into my fireplace, and you can see the little flames are on there. It's a gas fireplace, so I don't have to go stoke it. I'm lazy in that regard. But I could plug this cable directly into the CAN 4 card and it would work just fine. But I would not then be able to use the second CAN input that's on that card. If you don't need to use it, it doesn't matter, but I wanted to point out this cable because it's important sometimes to remember that you have that. And when you enable one or more of the CAN buses, I think you can just barely see a little blue LED on the corner here that shows that CAN bus number 1 is turned on the CN4 card. So that one is wired to the TCK8 in the distance with the thermocouple going to the fireplace. Now, this set of TCK8 modules here, I've talked about that earlier, you saw on the slide. And if I look at the bottom of this one, you can see the bottom one is the B version. That's what's shown there. You know, these pop apart, they kind of key together kind of nicely, so you can stack them up. This one in the cable that's shown there is actually plugged into the CAN bus right here on the Syscon using the standard, if I can get my arm over there far enough, DB9 cable that goes over to the side. But you can see just outside the frame, I've got a little DC power supply. So like I mentioned, if I'm going to do temperature measurements using the TCK hardware with the Syscon input, I have to have external power, and there's a special cable that has those little banana plugs you can see there that you have to plug into an external power supply. That's actually something we don't even normally offer, like on our price list. We can get customers that cable. It's a special order. We just have to know that, hey, I want to use external power with these TCK8 modules. It works very nicely then on the built-in CAN, and it saves you from having to use a slot for either the CN4 card that's like here, or even the T8 card there. So this TCK group I was going to point out is just this loose thermocouple, so that's measuring the ambient temperature of the air inside my office. Versus this T8 card here, you can see I've got a thermocouple plugged into channel 1. This wire comes over there, and I'm checking the temperature of my coffee. I like it to be at just the right temperature when I drink it. So I've got it in my my mug here. It's a little bit of an Easter egg for those of you that may have really good imaginations and can figure out what that logo is that's no longer on the cup. So that's what the T8 card is wired into in that regard, and I just plug it directly in. You'll see in the software I pick which thermocouple type I have, and I'm making that measurement. And then lastly, I talked about the possibility of using a DC input or just a regular channel input. So I've down here got, in this case, it happens to be a VB8-2 card. It could be a V8, a VD8. Nearly all of our modules, like I said, can measure DC voltage. But in this case, what I'm using is this little external signal conditioner, which lets me plug in one thermocouple. I set the switch to either Fahrenheit or Celsius. It just scales the output. And then I take that output that's on those banana plugs, use a little adapter, and plug it into a B and C cable. It goes directly in the front end there. These things are quite economical, and if you only needed a few channels of temperature, it also can be a very nice way to get that when needed. Of course, then I'm just using up a channel on my front end, a regular 8-channel input. In this case, I'm using it to measure my ice water temperature. We'll see that in the software as well. And this happens to be a probe that's set up to like go into an engine or transfer case or something like that. I should have maybe asked the services guy I borrowed this from if it's clean or not. Yeah, anyway, it's measuring the temperature of my ice water. So now that we can see the physical setup that we've got going on, let's look at the software and see how that gets set up. So here in Testlab Signature Acquisition or a workbook similar to this, I would go to my channel setup and put in the information that's required. So the easy ones, first of all, like I mentioned, in fact, let me go back to all the channels. So the T8 card that I mentioned in that first slot, all these first 8 channels are the ones that we can see here in the video, where I've got one thermocouple plugged in. This is the one measuring on the T8 card, channel 1, and it's in my coffee. That's measuring temperature. These kind of things, actually, there's no choice on a T8 because that's all this card does. And you notice all these other values are grayed out and fixed because it changes as needed based on the thermocouple type that's plugged in. And in the channel table over to the right, I here on this card get to pick which thermocouple type that I have. In this case, it's K because that's the one I plugged in. Now for the DC input channel that's on my VB8 card, so this is channel 9 in my front end, I've got that one set to DC voltage. Of course, this module has lots of different input modes. So I need DC voltage. I set the units to temperature, come across, it's single-ended versus differential. And ultimately, I need to also make sure that I put in this offset EU. Now, my little external fluke device is actually outputting 1 millivolt per degree, and that's degree Fahrenheit or Celsius based on the switch location. So like I pointed out on that website in my quick Google search, my offset is 459.67 degrees Fahrenheit. And it's important in here, because I actually made a mistake initially, that the actual sensitivity value is also set to millivolts per degrees Fahrenheit as well, because initially I had this on Celsius and I was getting a strange number. Well, of course, I said my calibration value was in the wrong unit. One other thing I'm going to point out too, and this is maybe slightly off script, but you'll notice that the light on the front end in this case is green in color. I'm not exactly sure how it comes through on the video, but all of our modules like the VB8 series, DB8 series, if you switch from single-ended voltage, which uses this just LEMO to BNC adapter, to differential, not only does it switch from using pin 9 in the middle of the connector to the shield as the ground, differential says, nope, I'm going to use pins 3 and 4 to measure a positive and negative DC voltage, but the light LED changes to blue. So it's a good quick diagnostic. If you're ever plugging something in, if you're using a LEMO to pigtail, a bare wire, and you see a green light, you know it's on single-ended, and really you're only using one of those wires. If you're intending to use 2 wires to measure a voltage on a VB8 or DB8, normally you'd be in differential mode and this light would be blue. So quick hardware tip for you as well. Now, I've skipped over thus far the CAN bus inputs. And remember, we have both TCK8s plugged in the CAN 4 card as well as to the CAN bus on the Syscon. That is in the setup for, not surprisingly, CAN settings. So in the upper right, I toggle the CAN settings and the system will show me which CAN buses that I want to use. So essentially, I can add lines in this table. Like in this case, in the CAN 4, I've got 1, 2, 3, 4 CAN inputs. Or I've got the one on the XSI or the Syscon that shows up here. So 5 total on my system because I've got 1 in the Syscon, 4 in the CAN 4. Ultimately, all I'm really doing is putting in a DBC file, which we deliver for the TCK8s with the software. So there's one delivered inside the software for Simcenter Testlab that is for the TCK8s. It's called TCK8AB. I've got a copy of it here in a local folder. But that reads in, and what that does then is allows me to come in and say, okay, I want to configure maybe all of the CAN inputs on this bus. So on my Syscon or my XSI, I say show view in CAN and then show all, and it says, okay, you've got up to 16 channels of thermocouple input. This, make sure I get it right, yeah. This one here on the table, that's my ambient temperature sensor, is the one plugged into the Syscon. I've got channel number 1 turned on, and I can give it a unique name if I want, set it up. There's linear or sample and hold interpolation. That has to do with how we actually read the CAN samples, because CAN bus, of course, is a bus where we're just reading a value in time, and how we interpolate between those is the settings shown here. Usually linear is going to be better to give you nice smooth data. Sometimes people want sample and hold to get the last value and not do any interpolation in between those samples. If I look at my CAN 4 card, you can see it looks very similar when I turn that one on for viewing. So now it's called bus CAN 2. It's the second one I've used up here. That's this bus number there. It's on my CAN 4 card. Again, I've got TCK channel number 1 turned on. And all the other defaults here are fine. And you'll notice once I've configured digital channels like this, they show up automatically down here in the lower panel inside my Testlab channel setup. So again, even if you've pre-configured them, you could actually go and turn them on or off, or turn channels on and off over on this side. But it gives you the possibility to configure, maybe I have all 16 channels on both enabled, but for this measurement, I want to not measure something. I can turn it off at this point without having to go back to the digital setup. And then last comment I'm going to make, you'll notice the point ID I'm using, I've got 2 colons. So I named this intentionally. So this is XSI or Syscon CAN bus. It's TCK8A channel number 1, and then I have : ambient. One of the display modes for online data is to use only this name after the : so I wanted to have that, and I'll show what that implementation looks like in the software. So that setup's pretty straightforward. All the definition is done inside the DBC file that's delivered with the software. So for these TCK8AB modules, essentially read that file in, turn on the channels, and you're good to go. So there it is. That's our 4 input channels, 3 directly temperature, and 1 a DC voltage. One other quick comment as well. I think we'll notice if I turn this off, I'll probably get an error. So the way our system works, I cannot measure only CAN bus channels. It's because typically CAN bus channels, like you can see here, are static, meaning when we take a time sample for any given dynamic channel, we get a single value for a static channel. So I have to have at least 1 dynamic channel enabled, In my case, it's convenient that I'm doing DC voltage for this other temperature through this little fluke device. But if I don't, I have to have at least one dynamic channel turned on. I can't measure only CAN bus channels. Quick comment in case you ever see that and you get confused as to why that's happening. Honestly, at this point, I mean, sometimes people might jump to acquisition setup, or I did want to point out calibration briefly. I did mention DC cal. That's here. So instead of AC calibration for like an accelerometer microphone, if I switch to DC calibration, I made that said, hey, you could use ice water and say I've got water at 32 and water at 212. I could then go make measurements at each of these points. It would measure a voltage value, and then it would calculate a slope of that line for me to give me a sensitivity that I could then apply to the channel that I've selected up here for my DC channel. Pretty straightforward, and also discussed in that support article that I pointed out. So if we jump over the measure tab, I'm going to start off on this display and hit ARM. So I think in this case, because it's temperature data, once it gets going, it will not really be all that thrilling, of course, right? I mean, you can see my ambient is this fuchsia line towards the bottom, my ice water is the blue, coffee is the green, and then my fireplace temp, the red up there, is the one that's sitting steady there just below 80 degrees. That one we'll see if the flames actually come on over here. That'll of course get up in the 100-degree range, but depends on how warm the room is, of course. My comment I made about the channel IDs, notice this I have intentionally displaying the whole thing. So this is on the CAN 4 bus number 1, TSIG 8 channel number 1. It's my fireplace temp, coffee, ice water, etc. Sometimes people are not aware that there's a possibility of using what's called a numerical display. And these can be really nice for things like temperatures, because I can use this, create a picture, and if I come down here and just look for numerical, when I add one of these into the display, and in fact it's in there already so I don't have to add another one, then it gives me the possibility of dragging and dropping channels from my data explorer into these little graphs. These can be configured though in a couple different ways. It can be a straight numerical like this. So it says, okay, my coffee's 112 degrees. If I pull that thermocouple out, it'll probably start dropping down. Yep, so probably seen the video, it's not in there anymore. Put it back in. There it shows me my coffee temp, fireplace, my ambient that's next to me here in the room, and my ice water over there down almost to 32 degrees. So that's nice and chilled in my little Siemens Yeti mug. But the gauge that I showed there has a nice setting where I can actually put in the ranges that I want. And at a quick glance, I can tell my coffee has cooled too much. I like my coffee to be between 120 and 140 degrees, and I set that color to green so I know if it's drinkable. If it gets too cold, between 100 and 120 degrees, it turns cyan. Or if I overheat it, or I ask my wife to bring me one, she's zapped it in the microwave too long, then it'll show up red up at the top of the scale.
You're very demanding about this coffee. They must love you at Starbucks.
Yeah, I know. I've had to go back multiple times to drive-thru and tell them to get it right. So no, not really. I'm not that picky. But it's a great example, Charles. Yeah. And then the ice water, you can see, like I said, there's plenty of ice in there, so that's nice and cold. But if that sat there too long, or maybe it's summer and that gets warmed up, I know I need to throw some more ice cubes in there before I drink that. And honestly, that's about all there is to measuring thermocouples. I can, of course, hit start. This will begin measuring the data in a standard throughput file. I set up here to take 10 seconds. I'm going to make something dynamic happen. I'm touching my ambient thermocouple, so that temp will go up at the end. But all right, there we go. If I got lucky, maybe the fireplace would have come on. It didn't in that case. I can say yes, save that run, and go take a look at the information. Disarm that. Jump back over to Navigator and say, all right, where's my throughput file? There it is. And there's my oh so thrilling temperature curves, where you can see that I grabbed that ambient thermocouple right at the 9-second mark, and it got slightly warmer before the measurement ended. So there we go. My coffee is down to about 111. My ice was at about 34 degrees. The room was right about 70 where I like it, and the fireplace a little bit warmer at 76. And that's all there is to measuring temperatures using Simcenter SCADAS hardware and Testlab software.